Okay, so here's our second example, and so what it says is use the graphs of f of x equals x squared plus x minus 6 and g of x equals x to graph the following. So we're given a quadratic function and a linear function again, and you'll notice that the graphs are already given to us, and we're looking at finding the product of the two functions. So this is going to be equal to f of x times g of x. Oops, that's essentially what we're looking at. And if we look at the functions, you'll see that this question might be very similar to one of the questions that you saw earlier in the lesson. You might have seen this in the warm-up. And so what this ends up actually looking like is a cubic function that looks like this. So I'm expecting to see a cubic function when I actually look at the product of the two functions. So that's just a side thing. You don't have to actually do that, but that's something for you to think about as you go through the problem. Okay? Multiplying a linear and a quadratic will give you a cubic function. So here's some other things you can think about. First of all, you want to make sure you multiply the y coordinates since it is a product of functions. The zeros of f and g. So because you are looking at the product of two things, then what that means is if you're looking at the zeros of those two functions, then they exist wherever the zeros of f and g existed from before. So if I look at the graph, I'll notice that there are three zeros. One of the zeros are at x equal to negative 3. One of the zeros are at x equal to 0. And then the last zero is at x equal to 2. The reason why I'm looking at both functions is because even if I take 0 and I multiply it by any number, I'll still get 0. And that happens 3 different times. Okay, so that's one thing for you to think about. The other thing you want to think about is if either one of your functions are equal to plus or minus 1, doesn't matter whether it's f of x or whether it's g of x. If it's equal to plus or minus 1, then what that means is the resulting value of y that you get is equal to plus or minus g of x. So think about it. If you're multiplying the function by a value of 1 or negative 1, you just get the value of the other function, essentially. Okay? So that's essentially what's happening. So here's an algebraic way of showing the exact same thing. So if f of x equals plus or minus 1, then f of x times g of x is equal to plus or minus 1 times g of x. Okay, so that's the proof for that previous statement. And similarly, if you want to look at the zeros, if you have f of x times g of x, and you're trying to figure out when this is equal to 0, either f of x has to equal 0 or g of x has to equal 0. Okay, so there's a couple of things to think about. So let's try graphing this. I'm going to try to find some values of x that have nice values of y for both of the functions. So let's take a look. If I have x equal to negative 3, then I have y equals 0 and y equals negative 2, y equals negative 3, which means when I multiply the two values together, I get 0 again. Okay, at negative 2, I have pretty decent looking values for y again. So I have negative 2 times negative 4, which will give me positive 8. And so that's up here somewhere in the graph. Okay, and then let's look at the next one. Let's see if I have decent y values. So that's negative 1 and that's negative 6. So that'll give me positive 6 as a result. So negative 1 times negative 6 is positive 6. 0 times anything will give me 0 again, so the zeros land back on the x-axis. Do I have a nice value here? I have a value of 1 and a value of negative 4. 1 times negative 4 is negative 4, so notice that it's the same value of the function that we had before. What about 2? Again, I have a 0 at 2, so I'm still going to have a 0 at 2 since I am multiplying the functions. And then at 3, I have a value at 3 and 6, which would give me 18, which is off the graph. So what the graph will end up looking like is something like this. And it's just going to continue onwards. So I end up getting a cubic function that looks like that. Okay, so I know it's a little bit hard to see with the other graphs there, but maybe if I go over it with another color, you might be able to see it a little bit better. Except the color is not really seeping through. But hopefully you get the gist of the idea so that you understand how to graph the product of two functions.